In this lesson, we're going to go over on how to draw the Titan 89L. Just like all the other parts in the Titan rocket series, this is a lathe part, so we would actually turn our material on a lathe to make this part. So let's take a look at the blueprint. We have our front view here. The overall outside diameter of our part is 950 thousandths. We have a section view that's splitting the part in half, and we can see that over here on the right hand side. In addition, here we have what appears to be a tapped hole on the end. It's indicating that there's a chamfer here at 45 thousandths, at 45 degrees. On the right hand side here, we have our overall dimensions of the part. Look, right here we're confirming that that hole is indeed tapped and threaded, or drilled and threaded. Looks like we have a little tiny radius here on our part. In addition, it looks like we got like a V cut here with a small little radius on the bottom of it. And on top of it, we have another radius here, and that's where that 2x is coming from. We have a detailed view going around the outside of our part, or the outside of our threads, and we can actually see that right down here for detail E. Down here in detail E, we got our thread relief diameter, and then we have our major diameter of our threads. Over here we have our isometric view, and then again we have another detailed view. It's just indicating, you know, what they're talking about here in this external data box up here. We have our major, minor, and pitch diameters. With that in mind, our external data, all this information can be derived from the machinist handbook. All right, so let's dig into Fusion 360 and make this part. So we're over here in Fusion 360, and we're going to create this part. This particular part, because it's a lathe part, we're going to start with some lines. We're going to go right down the center of our part and draw a horizontal line that needs to be 1 inch, 265 thousandths. We're going to use that 1 inch, 265 thousandths line to kind of anchor our part. And the way I would draw this part is I'm going to just draw in some basic geometry. Here's our thread relief. And so this is kind of the outside of my part. From here I'm going to add that little V slot. And then I'm going to add my circles. And those circles needed to be 120 thousandths, so I'll dimension those right now. I'm going to dimension this circle like this, and I'm just going to copy that dimension using a variable. Okay, so we have our overall shape of our part. We're just going to add some dimensions to it to kind of constrain it. So let's add those in right now. So first one I'm going to do is the overall radius of our part. According to the print, the overall radius of our part needs to be 475 thousandths. Okay. Notice when I moved that, or added that in, our little wedge down here kind of shrunk on us. That's all right. We're just going to grab these points. They're unconstrained right now, so we can just drag them around. It says the inside point is 375 thousandths, so I'm going to click on this point here, add that dimension in, 375. Okay, and I noticed something on the print, and I should have noticed this earlier, is the center of our circle here needs to be at 505 thousandths, so it's not actually anchored to this line. That's okay. So all we're going to do is we're going to click on the center of our part here, and we are going to delete this coincident constraint. So I'm going to click on the constraint that deleted it. Once it's deleted, I can drag it off the part. And do the same thing over here. Delete that coincident, drag it off the part. With that in mind, I know that this center and this center are horizontal to each other. So I'm going to add that horizontal constraint in. And then I'm going to add my dimension in. 505 thousandths. Now that we have, we're going to add in our measurements over here too. So for our thread relief, it says that this dimension is 300 thousandths divided by 2 because it's a radial dimension. Outside of our major thread, or major diameter here, is 490. Divide that by 2. I'm going to clean up my measurements here. At any time you can drag your dimension and extension lines around and kind of organize your workspace. It's good to organize this stuff so you can see all the dimensions at a glance. Now that we got our diameter measurements entered, we are going to enter our other dimensions. Coming right off the datum, we're going to find this first location. First location is at 125 thousandths. To the center of the point, 450. To the first location there, 350. To this location, 550. To the center of this circle, 775. To the outside of our thread relief, 900. This thing got a little wonky on us. We're just going to drag that around. And the back side of our threads at 965. Notice that our part is fully constrained. Everything is black in color. And we're ready to revolve our part. We're going to go to solid, down to revolve. We're going to choose this geometry. We're excluding these circles and we're excluding this little triangle here. So that's our profile. Here's our axis. We're going to orbit that part around. And that gives us our overall solid body. Okay, so we're going to go in and after the fact and we're going to add in some features that we missed. Modify down to fillet. First thing we're going to do is we're going to click on this line running right down the V block here. And we're going to radius that at 35 thousandths. I'm going to right click repeat. We're going to add in our little corner fillet. This corner fillet is created by the parting or the grooving tool that actually creates this feature. And according to the print, this can not be any larger than 20 thousandths. So we added that in. Now we're going to add our chamfers in, modify down to chamfer. Right click on that edge and that edge. According to the print, this needs to be 45 thousandths. Typical 2 times at 45 degrees. Right click repeat. All right, chamfer the outside of our part. And the outside of our part, we'll have to look at our notes down in the title block on this one. And it's indicating that this needs to be at 10 thousandths to break all sharp edges. We're going to put our threads on the shaft here. Create down the thread. We're going to click on this. We're going to go to model threads because I actually want to see what these threads look like. These particular threads are half 13. So half The decimal equivalent of ½ inch is 500 thousandths. Designation is 13. We're going to use class 2A. A indicates these are external threads, whereas B indicates they're internal threads. These are going to be right-hand threads. I'm going to press OK. Almost done with this part. Over here on this side, we have a tapped hole. So over here, there's a couple different ways to put this hole in here. I'm going to do it the quick and easy way. If we were actually making this part, we'd spend a little bit more time in calculating the chamfer that needs to go in there for the leads on our threads. But we're just modeling this part. It doesn't need to be perfect. So what we're going to do is we're going to use our existing datum location, or our origin, to anchor our hole here. So we're going to go up to hole. We're going to click on that datum location. Over here, we're going to be using a countersink hole because they are stating a chamfer on the outside diameter of this. It is going to be tapped with threads. Notice on the print they're indicating that the hole is going a little bit deeper, specifically 600 thousandths on the cylinder deep. So we're going to use an offset thread. So we're going to start typing this data in here. So the overall length of our hole is 600 thousandths. The chamfer diameter, well, again, as I mentioned before, they're not giving us a diameter, they're just giving us a chamfer width on here. So if we were actually making this part, we would actually do some better calculations on this. I'm going to do some rough calculations. What I'm going to do is I know the decimal equivalent of our major diameter of our thread, which is 375 thousandths. And all I'm going to do is I'm going to add 45 thousandths times 2 to it. So I'm going to add 0.045 times 2 in parentheses, just like that. And again, I don't know if this is 100% correct, but this will get us close for just a 3D model. These particular chamfer here is not 82 degrees included. It is actually 90 degrees included. So we're going to change that. And then the depth of our thread. Depth of our thread needs to be minimum of 350 thousandths. And again, this included angle here is actually derived from the drill bit, and they're stating that on the print at 140 degrees. Our thread needs to be 3/8. 3/8 16 is what our designation needs to be in class 2B, and then I, on this particular part, wanted it to be modeled. So I'm going to hit enter on the keyboard. It's going to lock that into place. Then I'm going to turn my origin off. So one thing I'm noticing right away is, just from experience, this chamfer is way too large here. Again, you know, this is something that there's some rules of thumb that we use as machinists. Generally, you want to chamfer about 1.5 threads in. So I'd actually have to take some measurements on this. Ultimately, it's what the customer wants, and on a part like this, I'd actually possibly ask for some clarification on that. So, but other than that, this concludes how to draw the Titan 89L.